CTTC in the scope of the ETSI ISG fixed 5G group. And well, I will try to showcase here a bit how we are implementing this the network as a service platform that we are well, designing and implementing. But before that, I think it's good for those of you that are not aware, maybe a very fast introduction to the ETSI ISG, the fixed 5G. The idea is that, well, all of us know that the wireless technology is evolving. We have different generations. Now we have 5G, 6G is on the go. The point is that in order to have the technologies aligned and be able to support this 5G, we need also to focus not only on the wireless, but also on the fixed, because somebody needs to provide support for the wireless 5G. So in that sense, the ETSI fixed 5G, it's willing to pave or to bridge the gap in how all these 5G services can be interconnected to the wired systems. Well, here is a small picture with the different technologies, capacities that are involved. Here you can see technologies like Wi-Fi 7, 5G PON, 50G PON, 400 to 800G for the backbone connection, and so on. Will not elaborate because otherwise I will run out of time. So, but that's what is known as the fixed 5G advanced network architecture, okay, and the technology requirements. What we are trying to do is with TeraFlow to control the end-to-end segment of this infrastructure. The point here is, okay, for the broadband services, we need to evolve, or they are evolving, let's say. And at home, we are increasing quite a lot the capacity that is required, especially because we need to manage high quality video streaming, for instance. In some cases, we might have applications that are latency constrained. Even worse at the business level, where we have even more restrictions. So we need to have technology that is aligned with all these requirements. Then we need to shift a bit the paradigm, because the classical paradigm is for best effort. And in best effort, essentially, the sales unit is the bandwidth. But then when different kinds of services with different requirements, different monetization schemes come into the scene, you need to include other parameters. Like in this case, for instance, a premium service might involve not only the bandwidth, but also the latency that you offer for the services. And when this thing happens, then you need to start separating the services into different classes, and each of them needs to be treated in a particular way, and also in a dynamic way. So you need to guarantee as much as possible the parameters of this connection in order to prevent possible fees for violating, for instance, the quality that you promise through the SLAs. So here is where the platform that we are proposing comes into the scene. Briefly, what we are developing, as I was explaining, it's a network as a service platform for quality on demand services. So the idea is that it's based on open source, it's based on standards. We are trying to follow as much as possible the standards. So that's one of the reasons why ETSI TeraFlowSDN and open source Mano and so on comes into the scene as a software stack. We try to follow camera quality on demand APIs, especially because that way we can expose standardized APIs towards the different stakeholders. And then here our platform supports, as I was mentioning, both best effort and quality of service guaranteed traffic over these fixed 5G advanced optical networks. We support the dual layer network slicing, because in this sense we are covering the packet optical, but also the optical access. So we are implementing differentiation of the services on top of this. And we are trying to follow vendor neutrality orchestration, also thanks to the use of this software stacks like TeraFlowSDN and open source Mano. You will see that the architecture that we are following is a bit sophisticated. It's multi-layer. It has many different blocks. I will try to explain them a bit. And we are trying to follow also a model-driven telemetry and closed-loop automation. In this case, we are trying to align as much as possible with also the ETSI ZSM for the closed-loop automation. Proposed standards, well, legacy monitoring systems like SNMP and so on fall short in what we need to do because they enable you to collect some kinds of telemetry, but it's not what we need when we are going to multi-layer and such level of sophistication of platforms. So we need advanced telemetry, we need closed-loop automation in order to realize this. What we are doing here is to leverage on the young push mechanism for proactive and subscription-based telemetry collection. And also in IETF SIMAP, which is a draft that is being developed at ETSI. There is still no final data model. All that we have are drafts of the concepts and some proposals, but still nothing materialized. But we think that's good because then if we implement at an early stage this proposal of standards in our standard software, that means we can try to motivate this the evolution of the standards. So that's what we are trying to do. At the end, as I was mentioning, we are based on a young push for the subscriptions between the different instances of the controller. I will showcase in a moment. And then we are trying to focus on the SIMAP, which stands for Service and Infrastructure Maps, for the representation of both the network topology, but also the telemetry data that is collected from the network topology. So with SIMAP, essentially what we get is a map of the different telemetry streams where they relate to, okay? I'm skipping a bit of the technical details because my presentation on it is a bit long, and if you have technical questions, maybe later, I prefer to answer them. In terms of the platform, the extended network as a service platform. So as I was mentioning, on top we have the Camara, especially the quality on demand that accepts the prompts from or the requests from the user. Velo, we have open source Mano as an end-to-end service orchestrator. Velo, we have an end-to-end instance of network orchestration based on TeraFlowSDN. Then this end-to-end, it's controlling both the access segment and also the transport segment. And then under this end-to-end, we have an aggregation network controller, again based on TeraFlowSDN, that is focused on the transport segment. You see that we have two transport segments. One of them is a classical best effort. It's based on classical IP routers. And then we have another one that is FGOTN domain. FG stands for Fine Grain Optical Transport Network. So the idea here is that with the best effort, we can provide the best effort services as we have right now on most of the internet. And with FGOTN, we can provide premium services where latency is constrained. This is based on time division, a form of time division multiplexing with some guarantees on both the latencies, the jitters, the capacities, and so on. So that way, the idea of the overall demonstration is at the beginning, we provision the service through the best effort network. If at some point best effort is not able to respect the specific quality on the on-demand requests and the SLAs that are agreed with the end users, what we will do is automatically switch to the premium services. Okay, so that way, what we try to do is to guarantee that the end user will have the appropriate quality, but trying also to minimize the cost of the final connection provisioning. Going ahead, well, this is the overall workflow for the demonstration. There is a first part of the workflow that relates to the creation of the service. The second part is on activating the performance monitoring for the service. And then the third part is whenever the service is not fulfilling the SLA, we trigger the switch mechanism from the best effort to the premium. Well, going for the first Zoom demo first. This is the detailed workflow. I will skip all the technical details. We can discuss them later in the coffee break. Otherwise, I will not have the time. I will just explain here that initially when the service is created, in this case, we are focusing on a game service. We provision at the cloud the game server that is required, and then we establish the connectivity between the user premise to the cloud through this stack. So here it's just the interaction between the different SDN controller and service orchestrator layers. And at the end here, the last step is where besides creating the connectivity, we also create the sitemaps, which are essentially these representations that I was mentioning that carry also the telemetry data for the end-to-end service. For that, we developed a game portal that essentially enables to emulate the end-user experience. Later, I will show it briefly to you. Then, whenever we provision the connectivity service, essentially, well, you see this. This is the representation. At the bottom, we have the overall network. On top, we have the sitemap layer that represents the connectivity at the IP controller level. So essentially, this sitemap here represents this connectivity between the ingress and the egress router. On top of that, we have the aggregation network controller that creates another sitemap that is in this case from the OLT until the egress provider equipment. Until the POP, my mistake. And then the upper layer at the end-to-end, it essentially creates the sitemap that represents the telemetry from the fiber to the room router at the user premises till the point of presence at the cloud. Okay, so that way we can monitor the end-to-end network segment. And well, then on top we have the 3GPP slice model that represents the connectivity from the end user till the cloud server. This is the representation of sitemap, and here it's one of the interesting points that I want to highlight of why we are using sitemap, because the point of sitemap is that it enables you to include links between how the different resources in the network are interrelated. So what I can do is say, okay, in this case, the trans L1 link in this sitemap map, it's supported by links, the physical link L5 and L9. So this one and this one. Okay, and I know also that this endpoint site 1 and this endpoint site 2 are mapped to the router PE1 and the router PE2. At the upper level, I can do essentially the same. I can say, okay, this aggregation network 1 link has this SDP1 and SDP2 connection points that are mapped to the OLT and the POP2. And then the link is supported by the other link in the other sitemap plus the physical link L3 plus the physical link L13. So at the end, you see that I can have a hierarchy of elements and resources that one of them feeds the other. So then our platform, what it does is when you ask for a subscription to the end-to-end network orchestrator for the end-to-end L1 link, it automatically triggers the creation of all the underlying required subscriptions towards the different layers of controllers and the different specific resources. So then each layer keeps aggregating the telemetry data, and at the end, at the top layer, you get the end-to-end aggregated monitoring data for your specific service. So that enables you to monitor for each individual service, which is the telemetry. Okay, so in this case, we are considering the bandwidth and the capacity and the latency. For the extensions, essentially, as I was explaining, it depends on draft, and then we extended it with specific augmentations for the bandwidth utilization, the latency, and the related services that are supporting the such or that are affected by such telemetry. So this is essentially the augmentation. And well, I'm jumping now to the subdemo 2, and then I will showcase for the 1 and 2 together. So the subdemo 2 is essentially activating the telemetry. Here, well, again, this is when the game portal already provisioned the service. We trigger this part that is the subscription. Again, I will not go into all the deep details due to the lack of time, but the idea is that you first issue, establish young push subscription between, in this case, end-to-end and the aggregation network controller. This essentially triggers a number of subscriptions to the underlying controllers, in this case, the IP, for the best effort, and the FGOTN controller for the premium. And then it starts aggregating the telemetry data for the different layer and providing it upwards. Okay. And then it is at the end-to-end orchestrator, service orchestrator, where we perform the decisions and the monitoring if there is some violation of the SLAs. And well, this is just a screenshot of the user interface. Now let's jump to the demo here. Okay, so it's a recorded video to ensure that everything works smoothly. So this is the game portal. You see that the game portal, the network as a service platform. Essentially, it showcases the representation of the network part only. This is the TeraFlow web UI. In this case, you see that this is a controller for the end-to-end segment. It contains all the topological details with all the underlying controllers that are controlling each and every element. This is the one for the aggregation layer. You see it has essentially the two parts. At the left, it's the best effort. At the right, the premium. And this is for the IP segment, that it's the one that is below the best effort. So then here, at the beginning, we have nothing provisioned. We don't have also any application. We don't have any SIMAP and so on. And this is the game portal. So essentially here, when you log in into the game portal, you will get here some available games you can play. You launch one of the games, it will automatically trigger the provisioning of all the resources for the game service. So it will provision the connectivity, the servers, and so on. And then when it's ready to play, here you have the game. Here in this case, we are simplifying with a stream for the game. Then here, when we update the topology, you see here that it created automatically all the layers for the L3 VPN, for the network slice from the OLT till the POP, and also the network slice from the user router till the POP. And here we have all the details on the specific connectivity service that was requested. Then at the application layer, well, you see that essentially an application flow was created from the user device till the server, and also at the SIMAP layer, the end-to-end SIMAP was created. And this is the real-time monitoring of the network performance. Okay. And in TeraFlow, you can see that the different services were created at the end-to-end, at the aggregation, and also at the IP layer. Okay, so essentially here, I will stop this video and go back to the presentation for the third subdemo. Okay, so for the third subdemo, essentially now we focus on the bottom part, that is what happens when the SLA is violated. So in this case, essentially, what we will do is monitor the different parameters, and we will inject synthetically an alteration of the latency here. So we will increase suddenly the latency, for instance, representing congestion in the network. And what we expect to see is that in the game portal, we will get an automatic notification saying, okay, the service is not behaving as expected. Do you want to upgrade to the premium? And then the user can choose. Okay. what will happen essentially, it's this. I mean, the original service that was using a best effort slice will migrate to an OSU tunnel supported by the FGOTN network that is being developed and standardized by F5G. And here, for the switching, the first part essentially consists in creating the service at the premium. And whenever the premium service is created, then we tear down the one at the best effort in order to release the unneeded resources. And then let me showcase the second part. So here it's, again, the game portal. Now we have a tool that essentially enables us to inject synthetically. In this case, we will increase by 5 the latency of link L5, which is one of the links at the IP network. And then you see here that automatically the latency increased significantly, enough to trigger the notification about the service upgrade. So essentially, if the user now decides to upgrade the service, it will trigger the reconfiguration of the service to become it a premium service. So again, we will deploy the game server in a separate premise now, because we are using different premises for the best effort and for the premium, and we will reconfigure the connectivity automatically. So now we get the service running at the best at the premium. Okay. So essentially, this is the idea. And then what we will see here is that the services now changed from the, I cannot move the mouse, sorry, let me go back. So we see now that the service is going through the FGOTN network instead of the best effort. And also for the different layers, they are going through the optical. At the application, we keep the end-to-end service, but now through the other path. And well, and the SIMAP. Well, SIMAP actually here for the premium, it's not required, so we are not showing it here. And in TeraFlow, if we update, we see that now we have the slice number 2 that is going through the other POP. POP1 is the one at the premium. And we have also here, well, all the slices now going through the OPE1. So you see that the PPE and at the IP controller, the service disappeared. So we performed the migration from one service to the other. And now I go back to my slides. That, well, essentially that concludes this demonstration. I don't know if you have any question, comment.